Hey guys, so I still feel pretty terrible, but this is what we'll do instead. We're just going to do some notes on uh, on the interwebs. So today we're going to do section, and bear with my writing, it's not going to be great. 4.6 Equilateral. Ooh, that's an A. And Isosceles. Wait, did I spell that right? Isoscele. I'm going to erase that. Triangles is what I didn't write there. Is what's supposed to go there. Triangles. So this is not going to be a really in-depth, crazy lesson because presumably we know these things already, but I have to have them in notes so that you have learned them. So we'll start with an isosceles triangle. Isosceles triangle has two congruent sides. And has two congruent angles across from the congruent sides. So if we draw a picture, and you could do it to the right hand side of your paper instead of right here. If this is isosceles, I'm going to mark two sides congruent, and then in turn I'm also going to mark two angles across from them congruent. Wow, really? I think I had it the first time and I kind of choked. There we go. Yeah, that's an isosceles triangle. And then some other aspects of it. This is called the vertex angle, and we talked about that. And that was on one of our previous tests and quizzes. And this are the base angles. So what we're going to see is basically this type of thing, but then we're going to use the properties of an isosceles triangle to usually solve for a variable or solve for a missing angle, and we kind of did some of those on the review. So let's do an example. I'll see if I can squeeze it down here. There we go. Okay, so example 1. Find x. So we have an isosceles triangle. And I know that this is 35 degrees. And I am looking for angle x. So I'm going to use the fact that this is x, and I also know that this is going to be x because they're congruent, so I can mark that as x2. And then because I have 180 degrees in a triangle, I can say x plus 35 equals 180 degrees. So 2x plus 35 equals 180. And subtract 35. It's probably not going to be a nice number, but that's okay. 2x equals 145. Divide by 2, x equals 77.5. And there's our answer. Okay, and I can also use that to find a length. So if I do example 2, and we just draw a very similar, pretty generic sort of looking triangle. Okay, and if I know that this side length is, let's say, 14 centimeters, and I want to, sorry, I should have put that up there. Can I move that? No. Maybe? Ooh. This is fancy. Oh yeah. Move it. Move it. Come on. Yes. That is legit. All right. If I want to find x for this guy, and let's say that 3x plus 2 is my other side there. So if I was given that and I wanted to find x, then I can use that property that these two things are congruent. And just like stuff that we've been doing for a while now, I can say 3x plus 2 equals 14, and then divide or subtract 2, and I get 3x equals 12, and that means x equals 4. So really nothing insane there. Again, we've done isosceles and equilateral. People pretty much know them before you even came into the class, so hopefully it's not too mind-blowing for you. And your homework should be pretty straightforward, and you'll probably finish it before class is done. And then if you do, just make sure that you're doing something productive and not just talking about whatever you normally talk about that annoys me. Okay. Oh, where'd it go? There we go. Equilateral triangle, moving on. Okay. Has all sides and all angles congruent. Again, not a big shocker. So if I draw a diagram, I'm going to mark this so that all the sides are the same and all the angles are the same. And I have an equilateral triangle. And to save you the time, we're going to use that sort of property to do the same things that I did in the examples above, where if I give you, oops, I don't want to move that, keep that there. If I give you problems like this, then you can solve them using the fact you know that all the angles are equal and all the sides are congruent. And they're not always going to mark it for you, but if I tell you that it's an equilateral triangle, then you can just go ahead and mark it yourself. So just if it's not marked and they tell you, then you mark it and you're good. So they're not always going to be like this straight up or like as straightforward as these guys. So just keep that in mind. Okay, the last thing we're going to talk about today, which it's not going to be in your homework, but I just want to start talking about it because when I get back, I'd like you guys to have a little bit of what's happening here. I just want to have a little more space, just a little more. Yeah. Okay. No. Okay. Well, that's a real buzzkill. A little more space right there. Okay. I don't know how to fix this, so I'm just going to erase that, and I'm going to try it one last time. Please. Enter. Oh, enter. Okay, we're good. The distance formula. Is the last thing I want to talk about, because I want to make sure that you guys have had a little bit of practice with that before I get back for hopefully on Wednesday. I'm feeling a little bit better than I was this morning, but still not great, so hopefully I'll be back Wednesday. The distance formula is d equals the square root of x1 minus x2 squared minus y1 minus y2 squared. Okay, and for now, just accept that that's what it is. And I'm happy to go over like where does that come from, how does that relate to anything else, like what is this thing. But for right now, that's really all that I want you to be able to use. Okay, and some important points where x1, y1, and x2, y2 are the points whose distance we're finding. And the big thing is just boom. Okay, what we're going to be getting into is talking about coordinates and stuff, and so it's important for us to be able to find the distance between 2 points. So if I want to find the distance between x1 and y1 and the distance between x2 and y2, I'm going to use this thing right here. The distance equals the square root of x1 minus x2 squared minus y1 minus y2. And again, I have a really good example of sort of where that comes from, but just due to time, I have 4 minutes left in this, so we're just going to get through a couple examples, or maybe one example. So, example, I think 3 now, or maybe 4? 3. Find the distance between the point 4, 5 and negative 2, comma 3. Okay, and what we're going to do, and I'm going to have to kind of get rid of it for a second, but I'll bring it back, is we're going to substitute that into the distance is equal to the square root of parenthesis x1 minus x2 comma squared minus y1 minus y2 comma squared. Okay, where here is my x1 y1, here's my x2 y2, and I'm going to substitute those values and solve. I'm going a little fast because I have a 15-minute timer here and I'm sort of running out of time. I got 3 minutes left. So the distance, we'll go blue, is equal to, and I substitute in x1 is 4 minus x2, which is negative 2. So I'm going to put a parenthesis around that so that I don't mess that up. Minus y1 is 5 minus, and I'm going to put a parenthesis around this y2 as well because it's a 3. I just want to make sure that I'm substituting in the correct value because a lot of people might mess up this negative thing. And it's the square root of all that. So equals the square root of 4 minus minus 2 is 6 squared minus 5 minus 3 is 2 squared. I need a little more room. So it's pretty straightforward. You're literally just going through and substituting those values. The square root, 6 squared is 36, minus 2 squared is 4. Distance equals the square root of 32. And then to be completely finished, I'd like us to try to simplify these. And I'm not sure, I mean, I know you guys learned it in Algebra 1. I just don't know how much of it you've done since then. What is up with this? Why is this happening to me? Oh my God. I really hope that one of you is looking at this and be like, dude, Mr. G, are you serious right now? Is this real life? You don't know how to do this? Because, yes, it is real life, and I really don't. Okay. To finish this, I would do some scrap work over here, and I'd find the square root of 32, and I'd break it down to 2 and 16, and 2 and 8, and 2 and 4, and 2 and 2, and then that is, I have 2 of them, and 1 gets left, so this is going to be equal to 4 root 2. And if you have no idea what I just did, that is okay, because I'm going to make sure that you leave this class and you know how to do square roots. And if you feel like you've never learned or if they're complicated, I felt the same way. But I learned, and I have a good explanation on how to do them, and I will make sure that you leave knowing it as long as you're paying attention and you take some time. Okay, that is it for today. If you missed anything in here, I'm sorry, and you can go back and look at it. It was not very fancy. And your homework tonight is on the website. I believe it's section 4.6. I don't know that my page number is the same as on my online version as the physical book. It's page 329, but I don't know if that's true. So it's section 4.6. Just find that and then go to those numbers. And yeah, have fun with that. Good luck. If you finish early, make sure that you're trying to do something productive. And otherwise, I will see you guys hopefully on Wednesday. And have a good rest of your day. Peace.